Hello and good morning, students. I'm back again with another question from 24th January morning shift 2023. Okay, that is last year itself. Not even last year, sorry, this year itself, because today is 8th of December 2023. So, without wasting time, straight away we'll go into the question. So, as you can see, the question reads like this. From the photoelectric effect experiment, following observations are made. Identify which of these are correct. So we have four statements. Okay? Stopping potential depends on only on the work function of the metal. The saturation current increases as the intensity of incident light increases. The maximum kinetic energy of photoelectron depends on the intensity of incident light. Photoelectric effect can be explained using wave theory of light. In fact, in a nutshell, I should say that it covers almost all the concepts of photoelectric effect. In other words, you'll be able to solve this question only if you are well thorough with all the concepts related to photoelectric effect. Okay, so let us try to briefly understand what happens, why photoelectric emission takes place in the first place, and all the other related things. So you have a discharge tube here, okay, with the photoelectrode or photometal. You have another electrode here. So this, you have an ammeter which measures the photoelectric current. Then you have the potential divider. This is known as a potential divider. You can divide the potential as per your requirement. So this, from here electrons are ejected as light of suitable wavelength is made incident on this. So in order to attract the electrons, this is made positive. So this side you have positive terminal and this side you have negative terminal. Okay. So light of a suitable wavelength or frequency is made incident on this negative electrode. Electrons are ejected and they are captured by this. We call this as anode, this as cathode. So thereby completing the circuit, you can see the circuit gets completed and you have a current flowing. You have a current flowing like this. Since electrons go this way, current will be flowing in this way. So that is the photoelectric current. Now, discussing the options one by one, you can see, coming to the first option, the stopping potential depends only on the work function. Now, stopping potential is the reverse potential. Reverse means we have to change this into negative and this into positive. You have to apply reverse potential so that the electrons are restrained from reaching this anode. So that is, if you apply a certain minimum voltage, okay, minimum negative voltage, so that even the most energetic electron is just not able to reach the anode. So you can see the current will go off because the continuity breaks. Since the electrons are not able to reach the anode, here you can see, so the continuity is broken, thereby current reduces to zero. So that minimum potential which should be applied in the opposite sense in order to stop even the most energetic electron from reaching the anode is the stopping potential. So naturally it will depend on the energy with which the electrons are coming out, not on the work function, isn't it? Because work function is something which determines the minimum amount of energy which is required by the incident light to to make the photoelectric effect happen or to make the photoelectric effect take place. That is decided by the work function. However, the stopping potential will be decided by the energy of the most energetic electrons. So first option is wrong. Then coming to the next option, the saturation current increases as the intensity of light increases. Now, what is saturation current? See, whatever be the number of photoelectrons ejected per second from this cathode, if all the electrons are being pulled by the anode, and if all of them happen to reach the anode in the same time, that is per second, you can take it as per second, that is number of electrons ejected per second is equal to the number of electrons reaching per second, reaching this anode per second. Then even if you increase this applied voltage, that is anode cathode voltage, still the current will not increase. Why? Simply because all the electrons which are being ejected per second at the cathode are reaching the anode. So the number of electrons cannot go beyond that. So there is no question of increase in current, because current is after all what? The rate of flow of charge. And that rate of flow of charge is decided by the electrons crossing any section, which in turn is decided by the number of electrons ejected per second from this cathode. And that will be decided by the intensity of light. Because as you know, if you increase the intensity of incident light, so basically you are providing more number of photons to the photometal. And as per Albert Einstein's photoelectric equation, the outcome of a photoelectron, every single photoelectron is the outcome of one photon. However, not all the photons are able to eject photoelectrons. Efficiency is very, very less. In fact, less than 0.001%. Efficiency is extremely less, but whichever photoelectron happens to come out, that is always as a consequence of one photon. So that means when we increase the intensity of light, so basically more number of photons are made incident per second on the photoelectric photometal. So obviously more number of photoelectrons will be ejected, and as a result more number of photoelectrons will be reaching the anode. So therefore the saturation current will increase. So this is correct. B option, B the statement. Then coming to the C statement, the maximum kinetic energy of a photoelectron depends on the intensity. Of course not. Maximum kinetic energy of a photon will depend on the energy of each photon and the work function. Whatever energy each photon has, it completely imparts its energy to the electron, and that electron, it spends a certain amount of energy to come out. That minimum energy required to come out is known as the work function. Some electrons are fortunate enough to spend the minimum energy, namely the work function, to come out, whereas others are not so fortunate to spend only that minimum energy. They need to spend more energy than the work function. In any way, the total energy of each photon minus the minimum energy required to come out is equal to the maximum kinetic energy of the electron. So this maximum kinetic energy depends on the frequency of light and the nature of the photometal, that is work function. So this is also wrong. Third statement, statement C is wrong. Then coming to statement D, photoelectric effect can be explained using wave theory. In fact, in class 12th book, it has been clearly mentioned that one of the why wave theory was rejected, or why Albert Einstein's photoelectric equation was accepted here. In fact, I think many of you students, you don't know that Albert Einstein was awarded the Nobel Prize not because of his theory of relativity, rather than this explanation of photoelectric effect which he gave. He was awarded the Nobel Prize. Anyway, so the wave theory could not explain the photoelectric effect. And as per the wave theory, if you happen to apply the wave theory, then you'll realize that it will take even months, several months for an electron to gather or accumulate that much energy, which will be, which will enable it to come out of the photometal. Whereas, photoelectric effect is almost instantaneous. The moment light is made incident on the photometal, almost immediately the photoelectrons come out. So, wave theory could not explain the photoelectric. That was the reason why Albert Einstein made use of Planck's quantum hypothesis, and he assumed light to be made up of photons. Photons are much similar to small energy packets. Okay, they are just like particles carrying momentum. So this is also wrong. So the correct option is only B. So third option happens to be the correct answer. I hope that is clear. If you like my videos, my way of teaching, kindly subscribe and share with your friends and other acquaintances, your relatives, family members, etc. Thank you so much.